All right, so I want to pick up here. We left off here with the price of the bond getting closer and closer to its face value as time starts to run out. So I want to pick up right here. So that is your return is the same as the yield to maturity of the bond. Okay? This example illustrates a more general property for bonds. If a bond's yield to maturity has not changed, then the internal rate of return of an investment in the bond equals its yield to maturity, even if you sell the bond early. Okay, so your yield to maturity is always going to be the same. Okay, if the if the yield hasn't changed, so your internal rate of return will equal its yield to maturity, even if you sell the bond early. Okay, so it just goes to show you that it's running at a time, but your yield to maturity stays the same. All right, so they were showing you that here in this case. And these results also hold for coupon bonds. The pattern of price changes over time is a bit more complicated for coupon bonds, however, because as time passes, most of the cash flows get closer, but some of the cash flows disappear as the coupon gets paid. All right, so basically, we'll look at this example here. So in this previous example, we considered a zero coupon bond, right? Which is why the pricing was so easy. We considered a zero coupon bond. All right, and now we're going to look at the effective time on the price of a coupon bond. So consider a 30-year bond with a 10% coupon rate and a $100 face value. What is the initial price of this bond if it has a 5% yield to maturity? If the yield to maturity is unchanged, what will the price be immediately before and after the first coupon is paid? Okay. So here's the price of the bond, and again, we can use Excel for this, right? With 30 years to maturity, they use the equation, but and again, I think we calculated this before when I used Excel. All right. So you can go through you should go through this exercise using Excel all the time, right? Just to make sure you understand how to use Excel, the price of bond. Now consider the cash flows of this bond in 1 year. So immediately before the first coupon is paid, the bond now has 29 years until it matures, and then the timeline's as follows, right? So this is the timeline. In 1 year, right? 1 year has passed, right? Because it says it has 29 years until it matures, right? Everyone see that? Again, we can compute the, whoops. Again, we compute the price by discounting the cash flows by the yield to maturity. Note that there is a cash flow of $10 at date 0, the coupon that is about to be paid. In this case, we can treat the first coupon separately and then value the remaining cash flows, as in equation 5. But you'll notice now you received that $10 right here. All right, so that was handed to you. But now the question is, what's the price of the bond? But you'll notice here there's a 29 here. Everyone see that 29? Because now it's 1 year hence, so they're pricing it from here out. All right, for 29 years, and they're saying, well, you just received $10. So here's that $10 you just received. Note that the bond price is higher than it was initially, right? It will make the same total number of coupon payments, but an investor does not need to wait as long to receive the first one. We could also compute the price by noting that because the yield to maturity remains at 5% for the bond, investors in the bond should earn a return of 5% over the year, which is 185.71. Notice how you take this price here. This is the price of the bond at 5%, and it does come out to 185.71. So what happens to the price of the bond just after the first coupon is paid? The timeline is the same as that given earlier, except the new owner of the bond will now receive the coupon at date 0, Thus, just after the coupon is paid, the price of the bond will be right here, right after the coupon is paid, okay? As we saw, the price of the bond will drop by the amount of the coupon immediately after the coupon is paid, reflecting the fact that the owner will no longer receive the coupon. In this case, the price is lower than the initial price of the bond. Because there are fewer coupon payments remaining, the premium investors will pay for the bond declines. Still, an investor who buys the bond initially receives the first coupon and then sells it to earn a 5% return if the bond's yield does not change. Okay, so here's that 5% again, right? So let's go through this video and watch. This is a little complicated pricing configuration.
The effective time on the price of a bond. So you purchase a 30-year zero-coupon bond with a yield to maturity of 5%. So for each $100 in face value, what's the initial price of the bond? What did you actually pay for the bond? Well, remember, with a zero-coupon bond, you just have one cash flow. You get repaid par value at the end. So per $100 of par value paid at the end, at a yield to maturity of 5%, 30 years of discounting, that's worth $23.14 today. So that's what you will have paid for the bond. Now the question is, let's say that the yield to maturity stays at 5%, and you want to know what the price of the bond will be 5 years later. And then imagine you actually bought the bond at $23.14 and you sell it 5 years later. What's your return going to be? Well, let's think about what's happening here. You're buying a 30-year bond when it's initially issued. Okay, so it has a $100 payment in year 30, and we figured out that the price is $23.14 today. 5 years later, here you are at year 5, and you want to know what's the price. Well, the only thing that's happened is 5 years have passed. The only cash flow is still $100 at the end, but instead of it being 30 years from now, it's 25 years from now, right? So the price, when there's only 25 years left maturity, you still have $100 paid at the end. The yield to maturity hasn't changed. That's the assumption in the problem. But instead of having 30 years to go, you have 25 years to go. And when you actually calculate that out, you get $29.53. The price is higher because you're closer to when you're going to get paid. So the present value of $100 in 25 years is more than the present value of $100 in 30 years. The question is, let's say you bought it at $23.14, sold it at $29.53. What's the return you earned? Well, if you remember from Chapter 4, we learned how to compute the return on an investment as future value over present value to the 1 over n minus 1. Right. And so the future value is what we actually sold it for, $29.53 in 5 years. We bought it now times 0 for $23.14. 5 years went by, so n is 5. Subtract off the 1, and you go through the calculation, and you find out 5% is your return. And that's not actually that surprising, because we know the yield to maturity didn't change. So if the bond is offering a 5% yield to maturity, the yield to maturity doesn't change. All you do is you buy the bond and you sell it 5 years later, you should get your yield to maturity, your 5% return per year.